professionalvmware.com vBrownBag. With us tonight we have Adam Eckerle kicking off our VCAP-DTD series. I am your host, Jonathan Frappier, and along with me to co-host tonight is Josh Atwell.
Hey guys, how's it going?
Adam, how you doing other than some internet problems?
Yeah, you know, funny how that works, huh? Like sweating from running up and down the steps, and finally I just gave up.
Excellent, excellent.
Google Fiber can't arrive fast enough.
And I lobbied for it. I really did, but we got passed over.
Next year. For the folks listening along, we've got the GoToMeeting window. If you have a question, you can pop your hand up, type in a question into the question window, or if you're on Twitter, you can use the vBrownBag hashtag. We've got our shows in APAC, EMEA, Latin America, our OpenStack show that I keep leaving on here, but should be actually kicking back up soon. We're looking for some topics and presenters currently, so hopefully around the summertime we will have that back in line. Recordings, if you couldn't make it live, up on iTunes at bit.ly/brownbag iTunes, and for those not on iTunes, bit.ly/brownbag podcast. Again, our guest tonight, Adam Eckerle. You can find him on Twitter at X79. Josh is at Josh Atwell, and I am at J Frappier. And one last quick note, if you haven't seen it already, the community survey we have going on, if you wouldn't mind hopping over, answer a few questions about how the community has helped your career, if at all. We're collecting information and getting a sneak peek to some of those. It's certainly some interesting data that's coming in, and would really appreciate folks who could check it out. With that, I'm going to try and make Adam the presenter. We'll see how good your hotspot is there. And you should be getting that now.
Yep. So hopefully you can all see my screen, or maybe momentarily.
Yep, we got it.
All right, good deal. So I don't have any crazy animation, so that's good. But yeah, welcome everybody. A little bit about me. I currently am a TAM for VMware, a technical account manager. That's a whole different conversation in and of itself, but essentially what I do day to day is I work with a very small set of customers, 3 to be exact right now, and just sort of consult and be the face of VMware for those customers. So whether that's support, escalations and, hold their hand during support issues, or provide roadmaps, or on-site betas and POCs, all that kind of fun stuff. That's what I get to do. So I've been doing that since mid-January. I came from a pre-sales background and consulting before that, but I worked for a VAR here in Indianapolis, which is where I live full time. As Jonathan mentioned earlier, you can find me on Twitter. And then, at the risk of whatever, there's my email address. So not like you can't figure out these email addresses anyway. But, and I've got a bunch of letters that mean different things for certifications. And then probably my I'm most proud of being part of, the vExpert, Cisco Champion, the EMC program. So lots of cool benefits. If you don't know about those programs, definitely look into them, find out more about them if you're socially active. They're pretty cool stuff. And then, go ahead.
You effectively have the what is it, the EGOT of the industry. You've got vExpert, Cisco Champion, and EMC Elect.
It's the Triforce.
Oh, the Triforce, is that what they call it? Excellent.
Well, I just that's what I call it. I just saw somebody else tweet that. But yeah, that's pretty cool. And then, outside of all this technical stuff, this is probably how most people used to know me. I'm huge into motorcycle racing and all that kind of stuff. So that's really probably a mugshot if you knew me 5 years ago, what you knew me by. So let's start this off. Let's get into the fun stuff. So obviously we're talking about the VCAP-DTD blueprint. What I like about these blueprint conversations, and especially around the design ones, is there's not a whole lot that's black and white. A lot of these things are open for discussion, and it depends, and all the fuzzy numbers and things like that. So I tried to keep it fairly autonomous, and I do call out some specific numbers here and there, but I tried to stay general and more design focused. So by all means, ask questions. I know Jonathan and Josh, you're monitoring the chat, so always pipe in. And this can be as much of a discussion as a presentation. The other thing I found out is actually collecting my thoughts and information around these two sections is that there's actually a lot there. So keep me honest on time, and we'll try to get through all of it. So let's dive in. Section 3, pod and block design. This is pretty fun because it can be very high level. We're not, it's kind of a good way to stick our toe into the pool of view design, pun not intended, I guess. So if we look at the major constructs of view, we've got this sort of overarching construct called the pod. The pod is just really a logical representation of all of the pieces of our view infrastructure. So that's desktops, that's vCenters, that's could include backup and underlying network and storage and all that kind of stuff. And I've got a diagram that kind of pulls some of this together. I'm a very visual person, so I don't like looking at words on PowerPoint, and I certainly don't like reading them to you. But that's kind of the major construct. And then we can break that down into building blocks. And we've got a couple different kinds of building blocks. One is our desktop block, as I usually call it, and that consists of basically our desktop VMs, and then there's one other piece of infrastructure that might fit in there, and that's the transfer server. So if you're doing like allowing your users to make an offline copy of a desktop, that goes through the transfer server. And there's some reasons for that, and we'll probably get into that a little bit later. But that's the desktop block, so pretty basic, right? And then there's the management block. Now, the management block is not unlike what you would see in a normal vSphere environment, perhaps. More and more customers are adopting the idea of management pods. Josh over at VC, I know you're very familiar with management pods and the AMP. And a lot of reference architectures call for management pods as well. FlexPod, vSpecs, those types of things. So basically, all of the supporting infrastructure, we want to separate off into its own little area. And there's, a few big reasons for that. One is that our workloads are different between, the desktops and then our management systems. Two completely different workloads, and we can be much more efficient and effective in our resource utilization and distribution if we separate those two out. And then the other is sort of, fault domain, right? So we don't want something in, making a change to a managed simple graphic. And here you can start to see, we've got our management block here. This big blue oval sort of represents the pod as a whole. And then we build on these building blocks. And you've got desktop block 1 and 2, 3, all the way out as far out as we want to scale. And of course, we've got some underlying access infrastructure, networks, firewalls and VPNs and load balancers, and then sort of the one thing that's missing from this, and I should have added it in, but storage. we got to have storage, even if we're using local storage. We got to have it in there, so that it's an important piece of this. And then if we kind of go back to this guy, this sort of puts it all together, and it looks really complicated, but as we start to digest this, I think it becomes a little bit easier to consume. As we look at these blocks, and something that I kind of glossed over, but it was on the previous slide, is that this pod is maxes out at about 10,000 users, and that's one of those fuzzy numbers that I've seen pods that are a little bit larger than that, and I've seen designs where they couldn't quite get to 10,000 users for any number of reasons. But that's generally where we try to delineate the size of a view pod. And then each of these building blocks is limited to about 2,000 users. Same kind of fuzzy number there. And that's because we want this vCenter to support no more than about 2,000 concurrent desktops. And so then each of these building blocks, right, has each of these major components. We've got the storage, we've got the hosts, we've got the desktops themselves. These things are in the desktop block, right? And then we've got the management block that has basically all of the supporting pieces. And I like this graphic because it includes, SSO, and it includes the security servers and Active Directory and DNS and DHCP and SQL and all those fun things. So you can really sort of see the overall architecture of what our design is going to look like. And now once we kind of graduate onto the next few topics, you at least have some visual idea of where all of these different pieces will fit in. But the key thing to remember, the key takeaway really, is the two different types of building blocks within our pod, and that's the desktop block, which is simply our desktops and our transfer servers if we're doing offline, and then also the management block. So everything else that supports our users and our desktops goes under that management block. So one other thing I want to talk about before we kind of move on to the next section, database architecture, is connection servers. So if you've got your VCP desktop already, you have a good understanding of connection servers and their role. And I don't really want to re-explain everything, but just to give you an idea, think of the connection server as sort of the gateway to the desktops. Users, unless they're doing like direct connection, have to go through a connection server to access the pools of desktops that they're entitled to. So in a pod, we can go up to 7 connection servers, and that's 5 active connection servers, like behind a load balancer perhaps, and then 2 standby. And this is a typo that I fixed, and because of my internet crapped out, I didn't see the changes. So disregard this per pool, it's per pod. And so the reason why there's 2 things that happen on the connection servers that are important. Well, there's more than 2 things, but for the purposes of this conversation, there's 2 things, and that is the replication between those connection servers. So when you install your first connection server, it's a next finish type of install on a Windows box. Pretty simple, not much to do. And then once you start scaling that out and you add your second server, it's pretty much the same next finish with the addition of, pairing those connection servers together. And what happens is there's an Atom database, Active Directory Lightweight Directory Services database, that holds the configuration information for that connection server. And that Atom database gets replicated out to the additional connection servers. So pretty simple. It's nice and easy. It doesn't take a whole lot of thought. And that replication is very lightweight. Again, it's configuration information. So unless you're just making configuration changes all day and all night to your connection servers, God help you if that's what you do, there's not a whole lot of traffic to worry about. So then why only 5 active connection servers? And the reason around that restriction and scalability really comes from the Java message system, which houses the event logging. So log on, log off events, recompose events, rebound. All those types of activities get logged to this JMS system, and that gets replicated to all the connection servers. But that is a mesh replication. So if you think about each one of those connection servers replicating all of these events out to all of the other connection servers and vice versa, that's a lot of traffic. And then couple that with the latency and things that have to wait for session states and all these things, it really inhibits how we scale the connection service. And I wish I could tell you that like the next version this was going to be different. Maybe it will be, maybe it won't. I just don't know. But this has sort of been a thorn in a lot of larger view designs. So I'm definitely interested to hear from the audience if they've seen differently or have designs that have run into this or anything like that. So feel free to pipe up.
Yeah,
so
I have a question actually.
Yeah, sure.
There was a post on one of the VMware blogs saying that the 5+2 rule was kind of, the +2 for redundancy, obviously, so you could service all 10,000 users, but the post was saying that you could actually run 7 concurrently live and spread the 10,000 users out over 6 or 7 servers, and that if one failed, you still were able to kind of stay within supported maximums for each of those servers. Have you heard that?
I had not, but I could definitely see where that's like a lot of things. That's just because you could do that doesn't mean you should. But I wouldn't necessarily have a problem with that. You just have to really be careful and monitor those connections. I would equate that to running on a cluster of 7 servers, and if you don't monitor, most implementations don't have a hot standby ESX host, right? So if you don't monitor those resources and you end up having an HA event and you're over that threshold, some of those VMs aren't going to restart. So in the connection server scenario, yeah, you can do it, and as long as you monitor and stay under those thresholds, and you can absorb a connection server failure, yeah, sure. From a design perspective, you just have to identify that as a risk. If you want to do that, that's fine. Just make sure it's documented, what the risks are going to be, what the pitfalls are going to be, and move forward with it if the customer wants to do that.
Cool, thanks.
All right, so let's move on. If there's no other questions, let's get past here to the next. Oh, and yeah, so a couple things. There are some additional things that we get to play with. And most of this stuff I don't necessarily think is pertinent to the exam, but I just want to mention them real quick. If you're doing View 5.2 in newer designs on VCAP 5.1 and newer, we actually can use Heartbeat now to protect our vCenters, and it supports View Composer, which is a really neat feature. I know for whatever reason Heartbeat doesn't have mass adoption like some of our other technologies, but it's great technology, and the fact that we can use it with View now, we can really add some resiliency to our design. So just be cognizant of that more for your actual designs, not necessarily for the exam. And then again, be cognizant of two-factor authentication solutions, like RSA. You may need to know where they fit in, but it's I took this exam like a year and a half ago when it was in beta. So I don't recall there being a strong focus on security, but you may have to know if security is a puzzle piece, you may have to know where it fits in the solution. So RSA is probably the most common and there's a bunch of guides, a bunch of documentations. It's not that hard to design with and implement, but there are others. So just be cognizant of those. And Radius, and I kind of mentioned direct connection before. The ability to use the Horizon View client to connect directly to a desktop or a physical workstation even. In VCAP5-3, I believe that was allowed. So be cognizant of those options. I don't necessarily don't recall necessarily that they were on the exam, but it's probably good to know. The other thing around secure networks, what I'm really talking about there is, I worked for a company that we used IPsec in order to sort of have a jump network where we went into these specific VMs and they had IPsec connections to secured data. And you can do that same type of thing with View, and there's certainly different ways to do that, and I think that there's more elegant ways than not. But just be aware that we can do some things with secure networks in a more elegant way. And if you need to, hopefully you can avoid doing things like IPsec and using security servers and connection servers to your advantage and pair them to certain pools and topologies like that. And then last, Active Directory, right? This is not by any means specific to your View designs, but I think it's important to note that, yes, we absolutely want redundancy and resiliency in our Active Directory topology. That goes without saying. But I've seen different ways to accomplish that. I mean, some customers have dictated that they wanted a complete separate forest or a child domain for Active Directory just dedicated to their View environment. And that's completely possible and fine. There's implications there, but be aware that customers may require or ask for things like that and how those fit in. And then last is, we've got a ton of authentication and group policy and all these things happening constantly in our View environment as desktops are getting refreshed and logged on, logged off, recomposed. So if it is at all possible, I think that it benefit the designs greatly to have some sort of domain controller localized to the desktops, and connection servers even for that matter, to handle those authentication requests much more quickly, because that's one of the things that can kill a VDI implementation. One of many, right? But a lot of times it's not the application, it's not the underlying Windows operating system performing poorly, it's not the storage performing poorly. It takes me 5 minutes to log in, or it takes once I get logged in, it takes login scripts years to run and all that kind of thing, and it becomes a non-starter because users can't use the desktop. So be aware of some of the implications of Active Directory. It's one of those things that we kind of forget about sometimes, so that's just kind of why I'm bringing it up here. So any other questions?
So, Adam, we had one question that came up.
Yeah,
yep.
sure.
Yep. The question was, any idea when 2012 AD function level will be supported?
That's a great question. I don't know for sure, but you may have all seen that there is a Horizon View event, I believe, coming up second week of April, like April 14th. Stay tuned for that announcement. That may or may not happen at that time.
All right. Excellent. Thanks.
So I spent a lot of time there. Let's get moving. So database architecture. So we could get mired down in the mud here forever. And I think really the purpose of the blueprint and the DTD is not to make us DBAs. Sort of like with if anybody's familiar with the DTD. You need to know necessarily the inner workings of these databases, but you do need to understand a couple of things about them. Performance, where to put them from a storage tier perspective, where to put them from a server perspective, compute perspective really, and how they grow. Because if your database starts out with 2 gig, well, that's great, but you have to know how big it's going to get before you can really decide where to put it. So the first kind of thing, the 2 important databases are the Composer database and the View Events database. So the Composer database, again, just like some of the other services around vCenter, we can actually put that on the vCenter itself, which I would consider a local install. That has a couple of advantages. It's going to be faster to access that database if it's actually on the vCenter. Other than that, having it on a remote server, like a dedicated SQL server or SQL cluster even, I think is going to, those benefits of resiliency are going to outweigh, the minor improvements in performance. And separating out, those roles of that vCenter server. In very large deployments, especially around View, vCenter is just busy enough doing what vCenter does, managing the infrastructure, and then trying to roll on Composer, constantly creating and destroying desktops and cloning and all that, fun stuff that it does. We can not only separate out that database, but we can actually separate out the Composer role to a different server. So, I definitely think that having that database remote is going to be more benefit if you can design that into, or put that into your designs. And then the database doesn't really grow a whole lot. Again, this is a pretty fuzzy number, so take it with a pretty small grain of salt. But from my experience and from what other designs and implementations I've seen, it stays pretty small. 5 gigs, and if you want to say be really conservative, throw 10 gigs at it or 20 gigs at it, because that's a pretty small piece of the storage pie in today's environment. So you can be pretty conservative and safe from that respect. And then the other nice thing about really a lot of the databases, not necessarily just the Composer database, is that a lot of the parameters will be, laid out in the requirements. Whether that's the requirements gathering phase where you're doing on-site interviews, maybe the DBA team says, hey, we have a corporate policy that our databases are going to sit on this cluster, and the DBA group is going to manage them, and okay, great, that makes things a lot easier. You just need to make sure that that policy aligns with your design and best practices to an extent, or you design around that. Or you may have groups that say, we know we're going to use Windows and SQL for our database, but outside of that, that's all we know. And then you can kind of fill in the blanks. But a lot of times, much of the database discussion is sort of already predetermined, at least in my experience. Your mileage may vary. And then the View Events database, again, it's important, but it's events. Are you going to, what are you going to lose? You're going to lose statistics and being able to troubleshoot certain things if you lose that database. And then this is one that's going to grow, so you got to account for that growth. And I think this is probably the fuzziest number in this presentation that I have, but 1 to 2.5 megs per desktop per month. If you're doing this for 10,000 VMs, that's a pretty wide range of storage. So just be cognizant of that. And I tend to think that you can probably just use 2.5 megs per desktop per month in pretty much all of your designs, just as a sort of thumb in the air, being conservative, because the cost of storage is just come down so much that I don't really think we're going to break the bank with some dozens of gigs of space for this events database. And then last, again, not necessarily specific to View, but important to know, is using SQL authentication. In fact, in most of the documentation, I believe, and correct me if I'm wrong, but it actually calls this out as even a requirement rather than a recommendation. But using SQL authentication on your databases can help prevent the chicken and the egg scenario. So if you've ever had a customer, and I've had a few, that total system meltdown, and you're going in and there's no management cluster, so you have no idea where any of the VMs are. So what's the first thing you got to find? You got to find a domain controller, and if there's a dozen hosts, you're sweating, time is of the essence. The customer's saying, I'm losing, $80,000 a minute or $1 million a minute or whatever. The clock's ticking, and it's a high-pressure scenario because you have to have domain controllers online first before you can bring SQL servers, before you can bring vCenter and the rest of the infrastructure up online. Using SQL authentication prevents probably the wrong term here, but it aids in reducing the amount of time because we can bring those SQL servers up fairly right away, unless SQL services are dependent on Active Directory and all that kind of stuff. So there's sort of a waterfall of design decisions here, but know that SQL authentication is important for those reasons and to help us get infrastructure up quicker in those types of scenarios.
So Adam, we got a little bit of feedback in the question section. Ray Olander brings up that View Events database requires SQL authentication. And he also says that another point of view on SQL authentication, our security policies state we're supposed to use AD accounts for everything.
I've run into that one as well, and that's a bloody battle. So at the end of the day, in my scenario, it was we got an exception to the policy because we were able to show that, hey, look, the software vendor is not going to support you if you don't do it this way, if you don't use SQL authentication. And they were able to make an exception for that in sort of cave. I know that that's probably not the case in a lot of scenarios, so I'd be interested to know what eventually happened. Moving on to SQL Express, this goes without really mentioning, but please, unless you have to because you have a very small shop or whatever, don't use SQL Express. Use full-blown SQL, even if you have to co-locate it on your vCenter or what have you. Just use SQL Express in your labs. It's good for that. I'm not going to belabor that point anymore. And then last, maintenance and backups of these databases are absolutely critical. Again, I don't expect us all to be DBAs, but it is important to know, and I think you may even see questions regarding this on the exam, is around, all these databases, let's take a look at the vCenter database. There's probably a half a dozen SQL jobs that run against that database, over the course of a day or a week. And those jobs are very important. If you've ever migrated a SQL database or a vCenter database from one SQL server to another, you may have run into problems suddenly, like several months afterwards, and found out that those jobs didn't get recreated during the migration process. So make sure that those jobs are running and successful, and if they're not, do what you got to do to get those maintenance jobs back up. And then I hope that this is ingrained in everybody's heads, but backups are critical. These databases are important. If we lost either of these databases, it can be pretty catastrophic to the environment. So hopefully that's enough said there.
So Adam, there's a couple of more things that were brought up in the question section.
Sure.
Craig Baltzer brings up, and Craig, I apologize if I mispronounced your name. Tough battle with SQL authentication, showing an effective password rotation policy versus AD authentication, where it just happens. And yeah, I've seen that before myself. It is kind of tough to want to use SQL authentication and then keeping track of it.
Yeah, absolutely. Again, there's a bloody battle to be fought there, and it's unfortunate that's really the case, and that there's not better mechanisms to handle that. But yeah, I mean, it's sort of a necessary evil. If you've got those password policies in place, it's another thing to manage.
Yep. And then Graham Mitchell asks, how many months of events should we keep?
It depends.
Oh, you said it. Why did you say it depends? That's cheating.
I know, right? Drink.
Wah, wah, wah.
So, a lot of times, for larger customers, they will have logging policies in place that say we need to keep a year, 3 months, what have you. If there's nothing like that in place already that's going to dictate that, I would say that 3 months, 6 months, something around that order is pretty safe, because most of the time you're going to have an issue and you're not going to have to go very far back in the logs. A few days, a week, what have you. But there are instances where it is nice to have those longer-term logs. I don't think that I would say a year in most cases, but I think 3 to 6 months generally is okay. And I'm interested to hear what other people might say there as well. So let's move on. ThinApp. This is one of my favorite subjects, but unfortunately we don't get into it too deep here in the DTD. But I used to work with a guy, and I razzed him all the time because he absolutely hated ThinApp, and I loved it, so I always messed with him. But it's an important piece of the design, and we definitely need to understand how ThinApp works, and really more importantly, how ThinApps are going to play into the environment. If you've done your VCAP-DTD, you probably have a general understanding that that's good enough for the DTD. The only thing that you really need to add is around the repository, and understand the design decisions on whether we're going to include ThinApps in our master image, or deploy them via GPO, or stream them from an NFS share. There's a bunch of different options. So just understand those options, and the keys here are the requirements of the repository. If we're gonna leverage that feature in our view designs, and we absolutely don't have to, but for the purposes of the exam and the blueprint, I think it is definitely good to know how this all works. So it looks, any Windows file share, so array-based CIFS, DFS, just a plain Jane Windows file server will work for the repository. It sort of behaves like a file server from a workload perspective, but you got to think, if you unravel a ThinApp, there's a lot going on there. The sandbox, things like AppLink that are linking multiple ThinApps together. So there is definitely a different workload profile than regular unstructured data. So with that, I would definitely recommend you build into your designs time to test these ThinApps. ThinApps behave differently from one another. There's no real good rule of thumb that I've seen as far as how much bandwidth any given ThinApp will take if you stream it from a network location. You're going to have to use some fuzzy numbers maybe up front and then build in time to test. I wouldn't, like a Windows file server, you may be using, SAS drives or SATA disk to house that unstructured data. Don't do that with your ThinApp repository. I kind of alluded to this a while ago, but I've never heard anybody say that my applications run too fast. Slow them down, please. So if you can use 10K, 15K disk to back end your ThinApp repository, I think the customer will be happy with that. And then there's caching built into Windows File Services now. If you're using an array, they've got caching that's going to help that out. And I'm not necessarily talking about SSD, but as long as there's a mechanism in there, that's going to help some of the burstiness of launching bunches of ThinApps. And technically, you can do 100 meg connections to your ThinApp repository, but hopefully you don't even have that in your data center anymore. And be 1 gig, 10 gig, all the better. And then last, shameless plug, there's a super awesome ThinApp book that you absolutely do not have to read and understand for the purposes of the DTD exam, but it's an awesome book. It's a great reference. I wish I was a technical reviewer on it about 1.5 years ago, and I wish I remembered 10% of it since then. But like I said, I've got it on my bookshelf. It's a great reference, to learn all about the features and things of ThinApp. So take a look at that if you guys have time.
So Adam, excuse me, I've got a couple of questions that have come up here. With ThinApp, this is from Graham Mitchell. Is it also good with physical desktops? Can we move from a physical setup to VDI?
Absolutely. So I have a customer, a government customer actually, that has 21,000 seats at ThinApp and no VDI. So they were one of those customers that bought ThinApp on its own, and they use it all on physical desktops.
Good to know. And then Ray Olander brought up, any chance ViewAdmin will one day soon be able to assign ThinApps using AB groups rather than pool or desktop?
Oh, sorry. Yeah, so that's an interesting question, and I definitely want to say yes for two reasons. One is we can sort of do that today. Hold on, I'm going to cough. I want to do it in the microphone. Excuse me. So we, if you're looking at the ViewAdmin console, yes, we have to do it by pool, and there's no real good granular way to do that. But if you go outside of the view interface and you start looking at either logon scripts or GPOs, many of my customers, back when I was consulting, were deploying ThinApps that way, not even using the repository functionality built into View. So I know it's not, the integrated solution that we're all looking for, and hopefully that's coming, but it's not there today, so that's just sort of the workaround. And the other good thing about ThinApp, sort of along the same lines, is that you can actually build those security groups. How can I articulate this? But you can build that security into the ThinApps, so it will actually query AD to see if you're a member of a group that can run that ThinApp, and that's part of the package.ini file of the ThinApp. So you can have that extra layer in there as well. Because I know, some a few customers have created like the file share, and they want all their users to stream the ThinApps, and they sort of just plop all the ThinApps out in the central place, and then people go out there and they find the app they want and they launch, and then they put those security policies in place so that users can't launch ThinApps that they don't have access to. So hopefully that answers your question. So I think we've got about 13 minutes left, and we've still got quite a bit to cover in these last two sections. So let's keep rolling. Hopefully, we'll get through this. So these are two fun areas, and again, we're sort of building on some of the things we've already talked about. But one of the questions that I really like to ask, to validate understanding of some of these concepts is what is different about the infrastructure for VDI versus our normal server workload. And we've talked about some of these things, but just to call it out a little bit more, when we look at a VDI workload, it has a very different read-write characteristic than a normal server workload. Our IOPS per VM is very different. Even our RAM and CPU allocations per VM is very different. And then, what if I were to ask you, in a normal server virtualization environment, where are we most constrained, or where are we constrained most of the time from a resource perspective? I'm hoping that everyone is thinking memory or RAM, and I would agree with you. But in a VDI workload, we tend to be more CPU constrained. And there's a few reasons for that, but we're also running higher virtual CPU to physical CPU ratios. So we may be running as high as 4-to-1 maybe in server virtualization environments. And in VDI environments, we're maybe on the order of like 10-to-1 virtual CPUs per logical CPU. So some important things to remember, as why we're doing some things differently from a compute perspective, as well as from a storage and maybe even network perspective. And then, another thing that is sort of different is we use a very small number of client OSs for desktops. Maybe 2. Hopefully we're not doing new designs with XP, but maybe we have XP in Windows 7 or Windows 7, Windows 8. So that's 2 OSs. In a server virtualization environment, we've probably got 2003, 2003 R2, 2008, 2008 R2, 2012, Red Hat, Cent, and all these other Linux distributions out there. So we have a much wider range of operating systems. Whereas in our desktop environment, we're much more consistent across our VMs. And then, especially if we're using like linked clones, hopefully we're all generally familiar with linked clones, but then we're really minimizing the differences between our VMs. And then, sort of last is we have a much higher number of VMs, and they're much smaller. Where we tend to have fewer larger VMs in a server virtualization infrastructure. So let's kind of break down the different pieces of the pod and the blocks that we talked about before, into the main components. So hosts, we talk about balance, and the whole discussion around kind of scale up or scale out, and how many VMs do we want to put on how many hosts. And again, more fuzzy numbers, 64 to 128 VMs per host. I don't know if I want to say that that's typical, even though I did, but somewhere in that ballpark, that's kind of the density we're seeing with mainstream servers now. And obviously there's people that are doing much higher than that. Smaller shops maybe aren't that high, so somewhere in that ballpark. And then if you look at, again, like reference architectures where, based on Cisco UCS, for example, like your FlexPods and your vSpecs, you can go out to Cisco's website and you can buy blades that, they are 100 desktops per blade. So that's sort of your compute building block, and it's very easy and predictable to scale out. And I know other manufacturers probably have those things as well. But that makes this really easy and predictable. And then the other thing from a host perspective is the introduction of GPU hardware. So having those, NVIDIA cards, those Apex cards in our systems to do, whether we're doing CAD or multimedia or what have you, we have to take that into consideration. Where, especially if we're standardized on blades, some of the blades have mezzanine cards that we can put in there for GPUs. UCS has the ability to put these cards in there in a mezzanine form factor. I think other blade manufacturers do as well, but you have to be cognizant of it because if you have blades that don't have that ability and your customer is doing AutoCAD and view desktops, that would be something pretty terrible to find out after the fact. So just be aware of that from a host perspective. And then, the reason that I sort of talk about versions when we get down into the cluster layer, the DTD was really written around View 5.0 and vSphere 5.0 to an extent, but there's not a whole lot of version-specific questions and answers and things on the exam. But I think it's important to know some of the differences because, and maybe they've modified the exam somehow, but before we could only do 8 hosts per cluster if we were doing linked clones. Now that's gone up to 32 hosts per cluster in newer versions. So just be aware, and I think you can probably get away with either or on the exam, like I said, because I don't think that they've updated. But I think that that's something to verify, and maybe even a follow-up item where we can check with the certification team on that. But I don't see anything in the blueprint that calls that out any differently. And then, sort of I think the most common architecture for a lot of our virtual infrastructures is N+1 idea, where we've got enough hosts to serve our workload plus that additional host to in the event of a single host failure. And I see a lot of view environments, things like call centers that are just critical to being up, where they will build in N+2, N+3 even, to make sure that if they have host failures, they have enough capacity to absorb. Because again, we have many smaller VMs, and so if you take the example where we've got 100 VMs on a blade, and we've got a host go down, that's 100 VMs that are going to find a new home and reboot on a host. So having an N+2 or N+3 will really help absorb that big hit of all those VMs. So again, not necessarily something that's really specific to desktops, but be cognizant of that and make sure that you understand the design decisions around how much spare capacity is in the requirements, or be prepared to make suggestions.
So Adam, I have a question along those lines.
Sure.
How much, and pardon my ignorance of the VCAP-DTD, how much of the DTD that, if you can say, is about just general virtualization practice, or is it very specific to desktop environments? Because you're definitely talking about when you start looking at N+1 versus N+2 and making those design decisions, that's not necessarily specific to desktops, and it doesn't seem that it's that unique. There's nothing really specifically unique about it.
Yeah, no, I mean, there's definitely some overlap, and if my memory serves me well, the exam is definitely more slanted towards desktop-specific things. But like I said, there are some things about this architecture that do make it different, and if we're having very high density on our hosts because of we're able to go much higher, 80% utilization, then that is going to impact our spare capacity, and booting up 100 VMs versus maybe 60 server VMs or whatever your server density is, it's going to be a little bit different. So there's definitely some overlap, and the basic concepts are absolutely similar, but there are some things that make it different from general virtualization. So I know that wasn't a great answer to your question, but again, it's been a while since I took the exam, and I remember it being not a huge overlap with the DCD.
Okay, no, that's completely fair.
And the last thing, as far as clusters go, is resource pools. And the only thing that I really want to mention here is that, and again, this overlaps with general virtualization, but if you I shouldn't say it that way. If the best case scenario is you may not need resource pools at all. Resource pools only sort of do their thing when there's contention, and I think that the goal of of a lot of desktop designs are to have enough resources available and not have contention. I think in server virtualization terms, we're much more apt to have contention because of, we've got VMs of all different makes and sizes, and DRS is moving things around constantly. There's VMs with 1 vCPU and VMs with 32 CPUs, and there's just much more room there for contention and for us to have issues because of that. And I think view environments, because it's generally much more uniform, we want to have spare capacity and room for growth, and if we can do our math right, I think we can get away a lot of times without resource pools. But again, I think that's definitely an item that's up for discussion, and everybody probably has a different take on that. But that's mine personally. So moving on to the last couple things before we get to the last section, I'm going to try to breeze through these a little bit. Storage. The interesting thing with storage in View is that it's very modular. Our VMs have these different components. Persistent disks, non-persistent disks, our replicas if we're doing linked clones, and we have the ability to put those on different tiers of storage. So if we're doing linked clones, the replica becomes very important. That's where a lot of the I/O, maybe even most of the I/O, is served from a desktop perspective. So, a lot of times that's put on flash, whether that's local, if we're doing non-persistent desktops, or if we're doing persistent desktops and link clones, we can put that on, an all-flash array or a server or array flash. So just know, those are sort of the major components: disposable disks, replicas, persistent disks, and our normal OS, and understand what tier of storage that we'd like them to be on. Obviously disposable disks, probably not a ton of I/O going there, so that can be on your higher capacity disk. Obviously, this is again another thing that is sort of fuzzy in that if you can build into your designs or your proposals time to plan and test, definitely do it. And there's tools out there to help us with that. Like Liquidware Labs has a product called Stratosphere that helps assess desktop workloads before you virtualize. It can make recommendations and identify things that maybe are resource hogs or even poor applications to be, or desktops or even users to be pulled into a VDI environment. And then definitely size for I/O spikes. We kind of talked about this a few times in a different way, but it's really important in a View environment because there will be I hate the term boot storm, but there will be times when you have things booting up all at once. Maybe that's, your users logging in the morning, there's an I/O spike. If you don't have antivirus offload, like you're not using vShield endpoint, and you have antivirus agents in your desktop VMs, perhaps you've got a virus scan that kicks off at the same time. So make sure that you give a little bit more headroom maybe than what you would normally do from a storage perspective. And then, network, I think that there's a lot of overlap here. But, key being would probably be the default vSwitch ports. So if we're talking about doing 100 desktops on a host, the default is 120 vSwitch ports. So I've seen that in practice where you exhaust those ports really quick. Once you start getting close to 100. So I would just plan on maybe even just doubling that, or increasing it to a point where you're going to have plenty of room to spare. Especially if you think about having an HA event and having 40 or 50 desktops coming over to a host. You don't want those VMs to really fail because they don't have an available network port. And again, from a bandwidth perspective, all VDI implementations are going to be different. Desktops are going to perform differently based on OS, based on what's going on, based on the protocols that are used, RDP or PC over IP, or maybe you're using both. And then the settings that you've tweaked and changed for those protocols, and then also the content, right? If somebody's doing AutoCAD or looking at MRI images or just watching YouTube videos, that's going to be higher bandwidth. And there was actually there is some guidance around like what the average PC over IP session is using, and I think they can like 250K a second up to like 1.5 megasecond. And it's just I didn't include that because it just varies so wildly. And I want to underscore that if there's one thing that you can measure and test, I would think that this would be one of the more important ones. And again, there's tools out there to help us do that, whether that's Capacity Planner or Stratosphere again, or there's a number of organizations that have products out there to do that. So the last section, I think I've only got a couple, this and one other slide. So I think if you guys can stick on for a few more minutes, we'll get this knocked out. But again, Active Directory, it goes without saying the role that plays in our environment. But definitely recommend that you carve out specific GPOs for your view environment. That means your desktops, your servers, like your vCenters, and even your users. That one's kind of sticky, and I'm not sure I completely agree with that, but that's what the recommendations say in the document. Because mostly your users are going to already have a place somewhere in your Active Directory infrastructure, so you're not going to move those. But you may definitely have service accounts, and you'll want to put those view service accounts in those dedicated OUs. That way, it's much more easy to much easier to apply policies and things to those objects. And then, like we've talked about before, some customers may request a separate forest or even a child domain for a view environment for different reasons. And then last, or next, I should say, DNS and DHCP, obviously critical services. The one thing you got to be careful of with DNS is your scavenging policy. Make sure that VMs get created and destroyed and spun up, pretty quickly in a lot of view environments. So especially if you're using non-persistent desktops, so make sure that your scavenging policy is such that it will go out and clean all those old records out and update new or create new ones. And then DHCP lease time. This is my opinion. So I think that there's probably a lot of rules of thumb out there or a lot of experience out there that may deviate from 8 hours. I've got a customer that's running 1 hour, and they ran into an issue when the time changed, and so they had to bump it up to 2 hours, but they're running with a 2-hour lease time, and it seems to work. So I think that there's definitely wiggle room in this recommendation, and I think it would be interesting to hear what others' experiences are. But generally speaking, 8 hours seems to be typical. And last slide. So firewall rules. If there's one thing that should be pretty accurate in the documentation, I think it's this. And you don't need to go out and memorize the dozens of firewall rules for each of the different server roles, like the transfer server, the desktops, the connection servers, vCenter, Composer. All those different components have different ports and firewall rules that they are going to require. So I've just sort of outlined what I recall as being the most important. And I think a lot of us have some of these memorized already. But PC over IP, TCP and UDP 4172, that's probably one of the most important ones to remember. HTTPS, obviously, JMS, a Java messaging service. That's going to be important when laying out your connection servers, especially if you're putting them behind a load balancer. And then, USB redirection. That's really common in a lot of environments, but I dealt with and worked for healthcare providers and doing dictaphones through review sessions and things like that. This USB redirection port became very important. So I can't tell you how much time that energy has been spent, just by me and my customers troubleshooting issues when it's turned out to be incorrect firewall settings. So, just sort of words of wisdom, I guess. And then back sort of last thing to wrap up is two-factor authentication. Just be aware of what's out there, and sometimes customers will call out for specific technologies, like Imprivata or Digital Persona or RSA. Just be aware of those. You don't need to know really much about them other than how they may, layer into our designs. Like they will integrate into our security servers for two-factor authentication, like our RSA tokens. And then, this goes back to that use case where we needed we've got secure data. Maybe it's PCI data, maybe it's, health patient data that's in a very secure area, and we have to use sort of a jump box or a jump pool to get there. We can make if this is affecting a small number of users that need this two-factor authentication or need to access this data, just segregate them off into their own pool. Don't try to do one pool for your entire organization and then customize certain things in certain desktops to access that stuff. Just segregate it out into a separate pool. I know from an end user perspective that may be a little bit of an inconvenience, but if you can fight the good fight and get them to, just leverage it as it is and understand that it's the best way from an infrastructure perspective, I think you'll save yourselves a lot of heartache. And then, RSA is probably the most common thing that I see out in the field. So, like I said, it's pretty simple. There's a ton of guides available, and it doesn't really require much thought from an exam perspective. So that was the whirlwind of sections 3 and 4 of the VCAP-DTD. Hopefully that was good information, and let me know what you guys think.
I loved it. This was awesome. I've not been able to work on the view side of the world as often as I would like to, but this was great. I really enjoyed it, and lots of conversation going on Twitter. Jason Shiplett playing back up and sharing a lot of great information out there. So it's a good show when people are getting excited about the content.
Very cool. Well, this was a lot of fun. I'm definitely hoping to be able to attend the next two. And absolutely hit me up on email or Twitter with follow-up questions or thoughts. Say, hey, you were completely wrong on this. I'm definitely open to that. I obviously don't know everything. Who does? So let me know your feedback. If there's any other questions you have, just reach out.
Any audience questions out there before we let Adam go for the night and hopefully get his interwebs working so we can get off this hotspot? Josh, you got anything?
No, the only other question that I saw lingering, and I think it's been covered or is going to be covered in another session, was the whether the DTD is specific to a version of Vue.
No, I don't think so. When it originally came out, the beta was January of last year. And just like the DCD, there weren't, if anybody's taken that recently, I don't think there were really any updates that were specific to like 5.1 and 5.5 versus 5.0. I mean, if all you knew was 5.0, you could go sit to DCD and still be successful at it. I think the same holds true for the DTD, but I think we can probably engage the certification community and verify that. But I think most things are not specific, or if they are, chances are they're probably vCertif 5.0 and maybe Vue 5.1. So I know that's kind of a convoluted answer, but bottom line is I think we probably need to confirm.
We can certainly. I got John or Rashid and Linus Bork did a couple of VCAP boot camps end of 2013. So I've not listened to them in a little while, but there might be some information in there. I'll give a listen to those in the morning on the ride into work and see if there's any confirmation.
Very good.
And
well,
we got
thanks,
one other
Josh.
question. What does it cost to take the test?
I think it's just in line with the other design exams, so I think it's like $400.
Yeah, I think you're right. Not a small amount of money, but yeah, it is what it is.
Hopefully, our companies, most of our companies will reimburse us, but I know that there seems to be a growing contingent where they're kind of stuck paying that out of their own pocket.
Yeah, when I did the DCA and DCDs, they sent me the VCAP hats, which apparently they no longer do, and my wife got a real chuckle out of the certification cost versus getting a hat.
Yeah, I missed out on the whole hat thing, but you can buy them through the VCAP store.
Yep, good times.
Well, if that's that, I'm going to hit the stop recording button and say goodnight.